Hello again, fourth grade, and welcome to lesson 12-6. This is the last lesson in topic 12, and we're going to focus on looking for and using structure. So let's go ahead and watch our short video lesson, and then we'll get started.
How can you look for and make use of structure to solve problems? Think about this question during the lesson. Maps from two different ski resorts show a 1-mile cross-country ski trail for beginners. Show about where to mark 25 hundredths, 5 tenths, and 75 hundredths mile on each trail. What do both maps have in common? Both maps show 1-mile cross-country ski trails. Why are the maps not the same length? These drawings are from two different ski resorts and were not drawn to be the same. Think, how can I determine where to mark the points on each drawing? I need to analyze each drawing and decide about where the given decimals should be located on each. Think, how can I make use of structure to solve this problem? I can break the problem into simpler parts. Use what I know about decimal meanings to locate the points. Use equivalent forms of numbers. How can you break the problem into simpler parts?
Okay, so if we're going to break this into smaller parts, we need to stop and think, what do these decimals here represent? And let's deal with one of the drawings at a time. Now, 0.25, if you think of it like money, 25 cents is 1/4 of a dollar, right? Because we need 4 quarters or 4 groups of 25 to make 100 cents. So this is going to be 1/4. 0.5 we know is halfway because 5 tenths or 50 100ths. 5 is half of 10, 50 is half of 100. So this is going to be halfway through. And then 0.75 is going to be 3/4. So again, think of them as money. So 25 cents, 50 cents, 75 cents. So 1/4, 2 quarters, 3 quarters. So 1 out of 4, 2 out of 4, 3 out of 4. And then you can start working through these one at a time to decide where you're going to put your marks.
You can find 5 tenths first and use that to find 25 hundredths and 75 hundredths. Here's my thinking. The size of a decimal depends on the size of the whole. The size of the whole is not the same for each drawing. Divide each whole in half to show 5 tenths on each whole. How can you find where 25 hundredths is located after you locate 5 tenths?
Now for this part, it's telling us the point 0.5 is marked on each of the drawings. So locate 0.25 and 0.75 by dragging them into place. So we know 0.25 or 1/4 is going to be 1/4 of the way across. So if this is 1/2 or 2/4, that means the 0.25 is going to be halfway between this first section. So we're basically taking the first part and splitting it in half. For the second piece, same thing. We're looking at the distance from the start to the halfway point, and we're going to split that in half. Now you notice these are not in the same place on these lines, and that's because these lines are different lengths. Now 0.75 or 3/4, so here's our 1/4, 2/4, and we just split the second half into two parts to make 3/4 and then 4/4. So 0.75 is going to be halfway between 1/2 and then the 1 whole mark. Same thing on the other one, halfway between the 1/2 and the 1 whole mark. So even though they're not lined up as far as between the two different drawings, they are in the correct places when we're thinking about where they belong with relation to the starting point and the ending point.
Find the point halfway between 0 and 5 tenths to find where 25 hundredths is located. You can divide each half into 2 equal parts to show 25 hundredths and 75 hundredths on each whole. Do the same decimals align vertically on these number lines? No, the distance between 0 and 1 is not the same on each number line. Since the wholes are not the same, the parts are not the same.
Now you know how to look for and make use of structure to solve a problem.
All right, let's get into our notes and our guided practice. Now for our notes for this section, we are going to focus on the question, how can we look for and use structure to solve a problem? So again, we can break the problem into simpler parts. We can use what we know about decimals to locate different points on the line. And we can use equivalent forms of numbers when we need to. So for my first example, it says 3 people hike the same 1 mile trail. The distance for each hiker is shown in the drawing. Show about where the 1 mile mark should be on each drawing. So each one of them drew it out differently, but we're still going to find the same mark or find the marks on the different locations, on the different lines. So hiker number 1, hiker number 2, hiker number 3, they all start at the same point. But for hiker number 1, it tells us that this point is 0.5 of the way through, and we have to figure out where we would put the 1 mile mark if this is 0.5. So we know 0.5 is 5/10 or 51 hundredths, which we know is half. So we know the 1 mile mark will be the same distance from 0 to 0.5 as it would be from 0.5 to 1 whole. So I'm going to make the same size jump to put a mark on the number line to show where the 1 whole would be, because it's telling me this is the first half, so I need to measure the second half. Now for the second number line, the point that they gave me is 0.25. So 0.25 or 25 100ths. If you think of this like money, you know that 25 cents is 1 quarter, and you need 4 quarters to make $1. So 1 quarter is 1/4. So 0.25 is the same thing as 1/4 of the whole. So now we need to make 3 more equal sized pieces to make the 1 whole. So this size piece plus 3 more is going to give me 1 whole. So this is 1/4, 2/4, 3/4, and then 4/4 to get to the whole. Now for the last one is a little bit trickier. The last one, they gave me the mark, their first mark at 0.75. So again, if you want to think of this as money, 75 cents is 3 quarters or 3/4. So this is already 3 of those pieces. I need to find 1 more piece to make it 4/4 or 1 whole. So I looked at the distance from the starting point to the 0.75, split it kind of into 3 sections to figure out about how far each of those would be. And then I added 1 more of those sections onto the end. Now, here are some important equivalences for you to remember. 0.25 is the same thing as saying 25 out of 100 or 1/4, which is 1/4. Why do we know this? Because we know we can do 25 over 100 and divide the numerator and denominator by 25. So 25 divided by 25 is 1. 100 divided by 25, think of it like quarters. 100 cents divided into quarters is going to be 4 quarters. So that's 1/4. 0.5, or you can write it as 0.50, whichever you prefer, is 5/10 or 50 hundredths, which is half. We know this because 5/10, if you divide the numerator and the denominator both by 5, 5 divided by 5 is 1, 10 divided by 5 is 2. If you wanted to do it with this one, you could divide numerator and denominator by 50. So 50 divided by 50 would still be 1. 100 divided by 50 would still be 2. So that's half. Anytime you're seeing 0.5, you know we're talking about half of whatever it is. And 0.75 or 75 hundredths is 3/4 of the way. We know this again because we can simplify this fraction. 75 and 100 are both multiples of 25. So I can divide numerator and denominator by 25. 75 divided by 25 is 3. 100 divided by 25 is 4. So 0.25 is 1/4 of the way. 0.5 or 0.50 is halfway. 0.75 is 3/4 of the way. Another example we're going to look at says to find or estimate about where 0.3 and 0.85 are going to be located on the number line below. So we have our number line broken up into quarters, right? 1, 2, 3, 4 equal parts. So 0.25, 0.5, 0.75, and then 1 whole. So 0.3 or 0.30, remember, because we can put in that 0 placeholder, 30 is going to come after 25. So 0.30 or 3/10 is going to come after 25 hundredths by a little bit. And then 85 hundredths is going to come after 75 hundredths, just a little bit farther. So it's going to be between the 75 hundredths and the 1 whole. So remember, you can always add a 0 placeholder at the end to help make it easier to work with your numbers. For our guided practice, it says Margie painted 0.4 of her banner blue. Helena painted 0.5 of her banner blue. And we can see the drawings for both of their banners over here. So 0.4 and 0.5. Now it says for number 1, complete the drawings to show where the whole or 1 for each will be. So if I'm going to split this into equal parts, if this is a 0.4 and there was already a mark here before it, so we can say maybe this is 0.2 and then 0. So 0.2, 0.4, 0.6, 0.8, and then 1 whole. So this is broken up into, we're skip counting by groups of 2/10, so 20ths. For Helena's banner, they showed us that right here is the 1/2 or the 0.5 mark. So if this is halfway, I'm going to go the same distance to get to the 1 whole, because remember 0.5 is half. For number 2, explain how you decided where to draw 1 hole on each banner. So for Margie's banner, we had 2 marks, one after the 0 and another one that was equally spaced apart that was at 0.4. So if these are equally spaced apart, I knew I was going to be skip counting by 0.2s. So the first mark was 0.2, then I had 0.4, and then I continued making equal size marks to 0.6, 0.8, and then 1 whole. For Helena's banner, it was already marked at the 0.5 or the halfway mark. So I went the same distance that she went from 0 to get to 0.5. I went that same distance after the 0.5 to get to the 1 whole. Number 3, do the drawings show that 0.4 is less than 0.5? Explain. Now here we're going to say no, because if you're looking at these are not equal sized parts. So remember, if you're not working with equal sized parts, you cannot compare them. Same thing like when we were working with fractions, if you don't have a common denominator, you can't compare them. So we can only compare when we're using the same whole or equal sized wholes and parts. That's it for this lesson. If you have any questions, let me know. Otherwise, have a great day. Take care. Bye-bye.